What I've chosen to do here with my presentation is to talk about Indiana historic bridges that have been restored, rehabilitated, depending upon how you use this term. And invariably, it's something of, it may be a little something of each. This talk is limited to bridges in service on highways in Indiana. This is not about trail bridges. If I were going to do restoration, rehabilitation of bridges that are now in pedestrian service in Indiana, I would have to do another presentation that's 1.5 times as long as this one in addition. But, and so I kind of have this divided into two important sections. First is what I call a bridge gallery, and I'm just going to pass through. These are all bridges that have been repaired, restored, rehabilitated, depending upon, again, where you see it, in the grand scheme of things, on roadways in Indiana. And I'm not going to stop for much of this for long in terms of looking at it. It's a good thing you've got two screens here. I guess this one's a little more skewed than the other. And good bridge restoration, rehabilitation requires, in a practical sense, the work of, in part, some preservationists. That isn't the subject of this talk. It requires the work of consulting engineers who are interested and willing to work with the old technologies in some way or another, and with craftsmen. And obviously the concern of this workshop has a lot to do with craftsmen, and so that's kind of, I'm going to hang out there. But I just want to show you some of these bridges. You will notice in cases here, you have before and after kinds of shots. You have the actual costs of this restoration, rehabilitation, and you have, for the same period of time, the engineer's estimate for the cost of replacement of that structure. And in a lot of cases in Indiana, one will find that indeed these are all county bridges. They're not on state highway systems. We really don't do much preservation or preservation. I'll stick with that on state highways in Indiana. And in most cases, the restoration rehabilitation is less expensive than the estimated replacement costs. In one county we're coming to now, Orange County's got a number of these bridges, 3 bridges that it put together, 2 of them entirely with its own monies, simply because it was cheaper to do it with its own monies than it was to get involved in the federal aid system, period. One of the interesting things about Orange County was the commissioners decided that they would paint these bridges the county color. So we got orange, which didn't make the SPO very happy. But then these were now 106 projects anyway, because they didn't involve federal funding. Got put together, and then the Gospel Street Bridge is their premier bridge, and had some very special features to it, but I want to point out a bit of it here. Out you see down here in you will notice up there on the portal bracing that you've got the portal and the nameplate and the portal bracing. You notice the portal bracing has seen bad times from collision damage over time. So, but part of the project was in fact to restore by replicating this. And so what you got down here in number 1 at the bottom is, the best of what was left out of the 4 portal braces, cast portal braces. And then 2, Lynn Klingeman, you see there, craftsman who works on welding and wrought iron. made a pattern. And then what we have in number 3 is the pattern was used for making 4 cast portal braces in ductile iron. Another interesting feature about this bridge was the open web floor beams. Now here's one of these areas where you end up with compromise with the consulting engineer. You got replacement floor beams down on your right, the originals on the left, and if you look closely at them, you'll see that they're not exactly replicated. The replacements are heavier, and they're a bit more enclosed in the way in which they're put together. So to pick up on Frank Hatfield's comment earlier this morning, you got some of the aesthetic of it, and at least you don't have wide flange beams here to replace the original floor beams. You do have open web beams, even though they're not exactly like what came out. Now, of course, then you have the nameplate business, and you've got, you notice you've got some very special decorative features on the nameplate. Again, you see what we had originally in number 1. Number 2, we've got on the right Lynn Klingeman, and that's another key fellow in the world of restoration of metal bridges in Indiana, John Camden, on the left. And then you've got the best they could do in terms of creating a pattern, which was then again was a cast in ductile iron and put back on the bridge. This is an interesting bridge. This is the oldest bridge in the state of Indiana that was designed and erected by an Indiana metal fabricator, the Morton Marion Center Bridge. And the county didn't know this. But when the county engineer asked about this, and I gave him a hard time about the fact that they had taken down one Western Bridge Works bridge in the county, and Western Bridge Works was situated in Fort Wayne, where this, in the county, Allen County, where this bridge is located. And I said, you know, it's interesting, I'm getting inquiries from Iowa, that there's a Western Bridge Works bridge in Iowa, and they're fixing this bridge, and they're putting it on the National Register, but you guys, who are the home of this fabricator, are doing nothing with it. And he said to me, well, go find us a Western Bridge Works bridge. So I went and did the research necessary in the county records and discovered that this bridge was indeed one, and he did his part. This is entirely, I don't know what the cost of this was, but this was done entirely with local funds in terms of the restoration of the structure. Lambs Creek Bridge down in Morgan County in the center part of the state. This is kind of a little, not a truss, obviously, but a riveted plate girder. And that was done again largely this was done entirely with county funding. And it was done, you see the cost here. And by the way, some of us on the web a while back, there was a lot of questioning about, can you rivet cast iron? And you'll notice there that nameplate is riveted. Now, that wasn't historically riveted. As a matter of fact, they kept losing a nameplate because it was bolted in there originally. And the county engineer says, look, I'm tired of getting more stuff duplicated for this bridge. So he said, could you rivet that nameplate in place? So that's a piece of John Camden's work. Upside Down Bridge in Newton County, as it's called, or the Conrad Bridge is what I call it. It's a historic name. It's a Warren deck truss. Up there on the upper right and down the side on the right, you will see that you're seeing replacement members in which were riveted back into place. So this is essentially an all riveted structure originally, and it's been returned to its all riveted status in rehabilitation. You'll notice up on the upper left, this is a 1924 photo, shows you the original railing. And the railing was gone. If you look at down below on the left, the original railing had been removed. But we had managed to save the Elkhart Bridge Company plans, which is a deal I worked out to get them moved to the Historical Society for a tax write-off by what was left of the company. And so we actually got the original plans for this bridge. And so they were able to replicate the original railing for that structure. Friendship Road Bridge in Monroe County, another project that was done, I believe, entirely with local funds. Carroll County is another county where the will to keep cultural resources as well as save tax dollars has been an important function. This little truss bridge, this little Warren pony truss thing, was fixed for $1,750. It's not there, but the replacement estimate that the county engineer got was $100,000 to $150,000. And you'll see that the 17.5 got you from a 2-ton to an unposted loading. That's pretty good from the county's point of view. Xenia Bridge in Carroll County, 25. I didn't have in here the replacement cost, which was Ross. What was the number on that? $3 million was estimated, the estimated replacement cost for this structure. It's an old state highway bridge that was moved in the 60s to the county road system, and it just been basically moved and nothing had been done to it to speak of, and it's been completely rehabilitated or restored with a new deck at all. The Rapogi Bridge is another in the county, a bridge that, a relocated state highway bridge. As a matter of fact, if you didn't have these relocated state highway bridges in counties, we'd have nothing left of that heritage. The first whole decade of Indiana State Highway Department metal bridge construction is gone. And so thank goodness that some of it has been moved where it can be reused quite successfully on county roads and kept in decent shape. There's a great bridge down here at the in the southeast part of the county, the Lost Bridge, Dearborn 15. Now we get to the master, enough of the gallery. By the way, I want to be clear, what I showed you in terms of the gallery of restored or rehabilitated roadway bridges in Indiana is not a complete list. I could add 6-8 more to this. But I think this gives you, first of all, I want to spend time on Craftsman. I don't want to just go through a catalog for you here. Okay, you've got John Camden off on the left here. You've got Ross Brown, who happens to be with us today, and in the back. And we also have one of our premier PEs with us here today, Jim Barker. If we have questions and so forth, want to have time to be able to take advantage of their knowledge about some of this work too. But you see with John Camden over here on the left, he's created a heat shortening jig, which is a way of pulling that bar down and then heating it and upsetting it so you can shorten the bar. And over on the right with Ross, you've got him making a loop welded replacement rod out there. I want to start with the Bell Ford Bridge here, just to show you some of the kinds of things that engineers like Jim Barker and craftsmen like Ross Brown have thought about. This is arguably the oldest, at least partly metal bridge in the state of Indiana, 1868. A post truss that the west span went down on this. It's a combination bridge of timber and metal and wrought and cast iron. And this is the way it went down, and this is such a special bridge that the decision was made and funding was made available through transportation enhancement to repair, to take out that metal material and to repair it so that it could be put back up for highway use. Now, the story, not to steal the ending here, is this hasn't happened. Because the other span went down into the river too, and Jackson is a poor county, and so it hasn't happened. But the work that was done, that has been done, was done with the idea of fixing that metal, those bars. There you got good example up on the top left. You see the eye bar and on a lower chord piece up there that's twisted back on itself. Then on the bottom part, you see that eye bar being heated in Ross Brown's forge and being straightened out. And then on the right, you have in there in the center of that, you have that bar straightened, the same bar. So we're not looking at different bars out there. Some of the same kinds of work was done or has been done on the cast blocks. It's welding cast blocks that were broken for cast pieces, and you can see up here on the top left some of the drawings of what some of those cast pieces were like in this structure. And you see down below some of the blocks on the left that came through okay, and on the right you see some of the blocks that have undergone repair. That's welded repair. In order to make this work, Ross Brown created his own test rig. And the test rig,
Excuse me.
yeah.
Jim Barker designed it and came up with the idea, so I just did it.
Okay. I'm perfectly happy for the two of you to share credit or responsibility, whatever it is, for it. Thank you. Anyway, this test rig, the Barker Brown test rig, was created in order to be able to test eye bars and rods to see if those that had been repaired or those that came out that didn't look like they needed repair, but you wanted to check their reliability for putting them back in a highway bridge. You wanted to test them, but you weren't interested, of course, in testing them to destruction. So the idea was to figure out if you put this structure back together again with new timber and the wrought and cast iron pieces in there, particularly for tension, how much tension could you, given an analysis that Barker would make on what a member ought to be able to handle with, of course, the engineer's safety factor built into that, could that bar, if pulled, sustain that without any sign of distress or yield? That was the idea. And so anyway, Ross Brown built this bit, and then, as you can see on the upper right, it was he took it in after some cajoling and some swapping of materials with the Purdue Civil Engineering Laboratory. He took it in, and they calibrated and tested the pull on this to be sure that, in effect, it was working as he thought it was working, and as they wanted it to work. So this is the kind of thing that engineers and craftsmen can do in terms of working together on particular members. Now I want to go to Tobias Bridge, and you'll have to forgive me about the material on the right, but you know, I'm a card-carrying historian, and when I was going through the Jefferson County records, and I found those two Western Union telegrams posted into the record. you can imagine my excitement. You know, 2 carloads of bridge material sent, and there you are. Yes, sir, the bridge is here. And that is the Tobias Bridge here, designed by the Indianapolis Bridge Company in 1885. Here's a case where the county engineer came in. The decision had been made by his predecessor to replace this bridge. There is a state highway bridge parallel to this, about a mile or 2 miles off. This is a local road only. And he looked at the cost of replacement of this bridge, and he decided, this is a beautiful bridge and it's a waste of money. Why don't we just fix it? And so the new county engineer, Jim Olson, decided to fix it, and he went out and hired himself a different consulting engineer to deal with it. Now, this bridge has got these marvelous ribbon-laced verticals in them, and that have had some problems with them. On the left, on the extreme left, you see there's been some collision damage caused there. In the center portion, you see that somebody did what you might call, to use Daniel Luton's language, inexpert repair of an earlier era, and put an extra diagonal in there and attached it in such a way that it actually helped to make that particular vertical less straight. It put pressure on it in the wrong kind of way. I guess that involves a different kind of analysis of what you're up to out there. So, whoops, sorry, got the wrong way there. Here's a piece of the repair of that. What you see here is first the brace and jack that was used for lifting, taking the pressure off the vertical so it could be straightened. It was then heat straightened, the vertical, and then as a piece of the action, other plates were added on the outsides of the vertical to give it more stiffness. You will notice that down towards the railing, blocks were also added into the lacing to provide more stability to these very light and beautiful verticals down there as well. There was also some need to do, you saw John Camden's rig for heat shortening. There was need for some heat shortening here on a diagonal or so. And so, and that's Ross in here and some of his photographs of this. And you see him on the left putting in the rig, and on the right heating the rod that's been pulled together in order to upset it. This is the only substructure you're going to see here, but I couldn't pass this by. This beautiful north abutment. Tobias, back in the 1880s when he lobbied the county for this bridge, Tobias, who lived down the road from this, offered that he would provide limestone for the bridge abutments without cost if the county would put up a superstructure. And so this is the beautiful limestone that came, and in fact his descendants say that if you go back into one of the creeks that come off Big Creek here, you can still see some cut blocks sitting back there that didn't get used, that were employed in here. So there we go. There we go with the bridge as it is today, and we've got the bridge engineer down there. You see down below there. He's here today in disguise, sitting in the back of the room, not with his usual engineering dress on and top hat and all that sort of thing. This is a little different story. This is the oldest all-metal bridge in the state of Indiana, Boner Bridge, down in the county adjacent to Evansville. For those of you who aren't expert in the Hoosier countryside, or you don't need to be. But anyway, it was fabricated and erected in 1869, and it has a nameplate on the abutments of the names of the people who were involved, and they all went off and looked at a variety of, they decided, first of all, with the engineer they had, that they wanted a King patent bowstring. And so they went off to Louisville. You could do that easily on the Ohio those days. And they got a hold of the Barbaro brothers in Louisville, who showed them, who had erected a number of King trusses, bowstrings in Indiana and some in Kentucky. And the Barbaros offered them a deal that they would, in fact, they would build to the King pattern, but they would build with heavier members than King Company itself used. So that was the deal that was ultimately taken here. So this is it's a three-span, pony on each end, through truss center, and there's that, and there's the patent for the tubular arch, and this is what's a wonderful thing about this. It's got a cast iron piers to a patent, the Ives patent, in the substructure. So you have two sets of piers that hold up the center span here to that. Well, there you see the cast iron piers. This bridge is on a county line. To the west, the whole area has been consumed by strip mining. Then there's some reclamation area. There are very few people who live in that or around that. It's 2 miles south of here. There's a state highway that crosses the same creek. There is no need for a school bus to cross this bridge because school districts are by county. There's no need, given all the arrangements, for any emergency vehicles to cross this bridge. So it is a bridge in local use only, and much liked by the locals of the area and by some of us who appreciate the kind of construction and all that went into this bridge. The consulting engineers of record here got with the county got two transportation enhancement grants for the rehabilitation of this bridge. Here's where the story gets a little complicated, because when the historical societies under the 106 process got copies of what the engineers were proposing to do, they indicated that they were going to build a truss within the truss within this bridge, because this bridge wasn't strong enough, they said, virtually to hold up its own weight. And so I said, does this have to be? Do we have to have a truss within a truss here? Is this what we want? I came down here with a friend who's done some bridge work in Chicago, and we measured all the members of this bridge in the 3 spans one weekend. And we cajoled a PE from out of state to run in an analysis with these numbers using AASHTO wrought iron strength modes in there. And he came back. It was not a fancy analysis. It was a bar 7 analysis, and he came back with the proposition that this bridge, hands down, could easily handle 10 tons repaired. No truss. And remember the location we're talking about now. And so we sent this information off to the consulting engineer, who came back to us and said, oh, well, you see, you've really missed it. You've missed the whole point here. This is not wrought iron. This is cast iron that we have here. And since this is cast iron, you got the wrong numbers in the analysis in terms of dealing with it. Well, now, wait a minute, I said. We're not I'm not a professional, but you're going to tell me that bar out there that's bent in collision damage is cast iron, that somebody hit that and it didn't break. Then we got Ross Brown to come down, and we spark tested the bridge all over the place. And here's an example of one of the cases where we spark tested, and you can see the striation in the wrought iron. So that, by the way, is the consulting engineer's analysis that Ross Brown is holding there for this cast iron bridge. So this was one of those cases where we got a little nasty. And so I told the consulting engineers that we were going to, if they didn't change their tune about this bridge, we were going to call their professional competence into question in public. Well, you know what? They decided that they had coupons, by the way, they had sent off. I don't know what they couponed. Because they had results that said it was wrought iron, that was cast iron. I don't know, what they did for that. But anyway, they then decided it was wrought iron. And so the bridge has been restored. And there we go. And it serves the community and its function out there today. Another bridge, you can see some stuff up in Carroll County, Wilson Bridge. Remember, I showed you 3 earlier bridges from Carroll County. This is one more metal bridge. And here, there's some good points here. Yeah, you get into those bridge seats you see up there in the center, you don't know what you're going to find. You leave it to Jim Barker to find the critters, though, as far as that part of it is concerned. But all the bridge seats here were replaced, and a kind of neat system here. You can see down there, number 1, a sample bridge seat, replacement seat, and 2, you see it from a different side, and you see with a lower chord member bit that's going to be welded onto what's left of the original lower chord member out there. What's particularly neat here is the rig, because you see this bridge was not moved. The seats were replaced on site, and it was a very simple operation that Ross tells me one of the guys in the construction firm figured out about making that rig, which is so simple for replacing bridge seats. Now, this bridge seat business, I could have shown you probably a half dozen other bridges with bridge seats replaced. I think almost all of them with different ways of holding the bridge together while you move the bridge up to replace the seat. And there on number 4, you see the new seat, one of the new seats installed. It's everything. It's the channels have been welded back into place. It has not yet been riveted back. The cover plate has not been yet riveted back into place. All of the work on this bridge, by the way, rivets replaced rivets. Another element in this bridge was I-bar separation. And you see some of which up on number 1. And then you see these separations you see under 2 and 3, you see welding of these separations closed. And you've got some separations up above as well as down below. So pack rust, of course, is another element that Vern talks a lot about, and it's done a lot of demonstrating down in Indiana, and it's been employed along here. 1 and 2 shows pack rust along the lower chord. Number 3 shows you the upper lateral braces lifted and the upper strut. And 4 shows you the cover plate out. And you see more of that down below in 5 and 6. You see some of the damage at the end post in terms of lifting and moving stuff too. all of this was that along the top, as I say on the bottom right, there was a lot of replacement of 54 feet of cover plate plus all the splice plates along on each side of the top chord. Everything was riveted back into place. Notice up here on the top right, those upper struts were removed and plates welded to the bottoms of them before they were put back into place. And that's Wilson Bridge today, as you would see it, in terms of restoration and the estimated replacement cost. Brooks Bridge, this is one of the most recent ones. We're really basically up to this season. These are these 190-foot spans, Jim Barker? 190-foot spans here, rehabilitated this last season. You see before, and lots of work here. There was lots of all the channels were removed from up at the connections between 8 end posts and the connections with portal struts and braces. And so the system was, again, this bridge was not moved. And so how do you cut out that channel from the end post? Put a new channel piece in there. Be sure that all the, you measure properly, and what you're seeing down here see if I don't have that, number 4 is basically the new channel has been placed in there, but what you're doing with the portal is measuring against that to see where the holes of the portal come in, because you've got to drill all those holes. And then there's the drilling down here in the center at the bottom. Before you re-rivet everything. This is an all re-riveted bridge, just like others I was telling you about out there. So, and then there was also damage to some mid-level interior struts. There was damage to the verticals, and so there was some replacement of channel in there as well. Basically the same kind of operation. And then you've got some dude up here in the upper right actually climbing up there on it with the portal strut and bracing and so forth having been removed from that area. And down below, or there in that little insert top right, center right, is some of the pieces that were taken out of that bridge. Okay, more 4 feet of cover plate as well as splice plates, 36 places. Up there, down below on the right, you see, according to the construction engineer, 1,190 rivets were replaced with rivets in this structure. And that's the bridge today. If you were to come down and have a look at it in Martin County. Delaware County 130 is another product of this last year. Indiana Bridge Company, Camelback, 1902. Kind of neat connection over there with the hip hanger on the right. This bridge was moved. It was just lifted off its site and just moved down the road so that the repair work was done, because in fact it was pretty much taken apart. All the eye bars in there were taken out and ground. Bad parts were ground out, and every one was that needed anything was pad welded, and which included a good many of those eye bars. You will notice on the right, there's an example, if you look carefully at it, on the inside counter brace, the turnbuckle didn't work, and so it was cut out of there, and a replacement turnbuckle was put in, and an additional bit of the rod was welded into place, and we're back in business with it being adjustable. And this is I unfortunately don't have any replacement costs in here. But this is the cost of restoration. And the photo on the upper right was given to me by the engineer of record to show where they had removed pack rust and how well it had all worked in that process. And this is more of repair work evident in it. Between 1,000 and 2,000 new rivets, they told me, were driven into this structure in repair. So anybody who says it can't be done hasn't been to Indiana as far as that goes. So out at the very beginning, you may remember that picture of that bridge I had with my nameplate at the front of the title of this construction, Hibbs Ford Bridge. And this is another little story to this bridge I'm going to tell you. And this is bridges in my county, in Putnam County, in Indiana. It's not that big a deal. But the county has a favored consulting engineer. And the consulting engineer talked the county into applying for transportation enhancement funds to rehabilitate or restore this bridge to 12 tons for over $1 million. Now, this was a case, as far as I was concerned, where INDOT, in its wisdom, rejected the application. And so I went to the lead county commissioner from the district where the bridge is located. And I said to him, look, you guys weren't trying to replace this bridge, you wanted to fix it, repair it. And you made an application for $1 million+ to do that, for up to 12 tons. You got turned down. Suppose I find you an engineer who will oversee the restoration of this bridge for the 20% you were willing to invest in this bridge in the TE application. Not to 12 tons, but to 15 tons. That's just from my notion that these trusses were, if properly repaired, or most all of them were meant to carry 15 tons. And so the guy said, the county commissioner said, hey, well, that at least gets the bridge fixed for us. Yeah. So it happened. You see that guy, he's here today, but he's in disguise. Same guy who agreed to do this, the Hibbs Ford Bridge, for the 20%. And so it sits there today in Putnam County, repaired 100% with local funds, but repaired nonetheless. Okay, more to come. Quickly, what's up in the next year or so? Is this the end of restoration of highway bridges in Indiana? You better not believe it. Knox 45. This is 450 feet long. It's up on the docket. There it is. Boone 32 is just a little critter compared, relatively speaking, but it's to be repaired, restored, rehabilitated this next season. And then there's the Indiana Avenue Bridge in Goshen, Elkhart 403, right in the center of the city, Goshen. And those people care so much about that bridge that even though it's essentially one lane, they want it. And the county is going to restore it out there. Now, this is Pennsylvania Through Truss on the system in Indiana. We got several others that aren't on the system that we still have too. But this is a neat example of what can happen. And by the way, in that bottom right again, for those of you who, if any of you continue to have questions about whether you can rivet cast iron, note the decoration down there. And it is riveted into the railing through the bars there. Well, I can't close the whole thing without one trail bridge, right? A little sign of a trail bridge. But it isn't so much the bridge itself, which is pretty remarkable as a king arch beam structure that's got a good story to it in terms of how it was found in a ditch and all mangled up and has been fixed. But you'll notice that there is a cottontail that's crossed it here in the snow. So much for me and all of that. And if there are questions from any of you, either now or at the end of the session, I would be pleased to have Ross Brown and Jim Barker, who participated in not all of this by any manner of means, but important parts of it. We have a number of craftsmen in Indiana who do this work. Ross Brown and John Camden are the two most notable ones. We have a number of engineers who do historically sensitive repair work. Jim Barker is premier among that crowd. But I don't want you to think that we're just left with a single engineer or a single craftsman. If you provide business to craftsmen, they will come. Thank you.